Hey everybody, and welcome to the next video for the project Build a Data Analysis Library from Scratch in Python. In this video we are going to be completing step 6, Set New Column Names. In the previous video we retrieved all the columns in our data frame by issuing the command df.columns. So what we did to implement this was to write columns as if it were a method, which executed code. But we decorated it with the property decorator. So this basically converts columns into an attribute, meaning that there's no parentheses that need to be followed here to execute it as if it were a method. So we can still have lots of code executed by attribute access if we use this property decorator. So the property decorator also allows us to set attributes as well, and that's what we're going to be doing in this step. So when we issue the command df.columns equals a new list of strings, what's going to happen underneath is we'll be able to execute another method. So we have to use another decorator. And the pattern for this is that whatever attribute that you decorated with the property decorator, use that attribute name .setter and use that as another decorator to the same method name. So this method will get executed whenever our user does an assignment statement to columns. So any kind of assignment statement. So anytime you do df.columns equals something, that will trigger this particular method to be executed. So all the code under here will get executed. So this is part of the property decorator. And in fact, the very first one that gets defined is called the getter. So this is how you get or retrieve, some attribute by using, with the property decorator. The next part of it is called the setter. And so so this is the code that will get executed whenever someone tries to make an assignment statement. There's also a deleter, which we're not going to implement. So you could also define another columns method and decorate it with @columns.deleter instead of setter, and that would get invoked whenever someone writes the delete, df.columns. They use the delete statement, del, which is a keyword in Python. Okay, so with that said, we are now going to implement this method right here, this setter method for this property, this columns property. So whenever our user does df.columns equals something, that something will get passed into this method as the parameter column. So whatever is on the right hand side of the equal sign will get assigned to this columns parameter. Okay, so there's a few things that we need to do to complete this step. And they're all listed right here in this bulleted list. So the first thing is that we're going to require columns to be a list. So it has to be a list. So let's go ahead and do that now. So if if columns is not a list, so when we use isInstance to check its type, then we'll raise a type error and say something to the effect that columns must be a list. Alright, so that takes care of the first one. The next one is if the number of column names in the list does not match the current data type. So we're going to raise a value error. So we're also going to force our users pass us a list that has the same length or the same number of columns as our current data frame, which makes sense. So let's go ahead and do that. So if the length of columns does not equal the length of self._data. So remember, data is our dictionary that maps the column names as strings to NumPy arrays. So the length of that dictionary is the current length of the columns. So we will raise a value error here and say columns, or we can say maybe new columns must be same length as current data frame. Okay, so maybe that's a little wordy, and you can reword this to be a little bit different later. So the error message is important to be clear. So, but at the same time, you know, just getting something down and then moving on is appropriate, you know, as well, just to complete the step. Okay, so the next piece is we're going to raise a type error if any of the columns are not strings. So we are only going to allow strings to be column names. So what we're going to do here is we can go ahead and loop through them one by one, which is fine. So we could say for call in columns. And now if these are not strings, so if the column name is not a string, then we'll raise a type error and say all column names must be strings. Okay, so that takes care of that one. The next validation we have to do is to check to see if any of the column names are duplicated. So we're not going to allow duplicates, and we can't allow duplicates because our dictionary, we are using a dictionary to store the data. So dictionaries can only have keys appear once. So just by that alone, we're not allowed to have duplicate column names, and it wouldn't make sense to have duplicate column names either, as it would make it very difficult to know which one you're referencing. So what we're going to do here is, well, we could do this, we could continue in this loop, and that's fine. That's you could add some logic in here to check and see if there's any duplicate column names. But we're going to go ahead and use a little bit more clear statement. So we're going to say if the length of the columns does not equal the length of the set of the columns, then we're going to raise an error. So we'll raise a value error and say that you know, your columns have duplicates. This is not allowed. Okay. Now, the reason this works is because when you say set of columns, sets can only have unique values. So if there are duplicates in the columns list, then the set command will remove them. So if we say the length of that now non-duplicated sequence of items does not equal the original length, then we have a problem. So then we'll raise the value error. Okay. So that actually does all of the checks. The very last bullet point says to update the data. So we obviously need to figure out a way to change the keys in the data frame. So what we're going to do here is we're going to update self.data. And we need a new dictionary. And the way we're going to do this is we're going to zip up the columns, which now have been validated as strings that are not duplicates, or a list of strings that are not duplicates, that are the same length as the original. And we're going to get just the value. So what we're doing here, this zip is zipping up the columns with all of the NumPy arrays, and then this dict, whenever you give it a zip object, it will use the very first sequence as the keys and the second sequence as the values. So this will make you know, reassign the data for us with the new column names. Okay, so let's go ahead and run the test set columns to see if this is actually working appropriately. And I've already written it in here. So we have test set columns, and we can see if this passes. And good, it does pass. So let's go ahead and, before we end this video, let's go ahead and see how this works in the notebook. So here we are again in the notebook, and we have df over here, and this is from some previous work. So let's go ahead and reassign df.columns to be We'll just make it simple. Looks like there's 5 columns right now. So we did that, and if we just look at the underlying data, since we don't have a visual representation, you'll see that in fact our underlying data now has A, B, C, D, E instead of the original, which was, you know, these over here. So in fact we were able to reset the columns, it looks like correctly, and our tests verified that. And in the notebook we've just done some manual verification to do that, to see it as well. Okay, so that concludes step number 7, or step number 6.